There's a radar instrument on Cassini that is basically identical to the radar instrument that mapped the surface of Venus on the Magellan spacecraft in the early 1990s. And so we have been able to see down to the surface with Titan, and I want to show you now what we found. This is one of our first pictures taken with our cameras. And if this looks puzzling to you, don't feel bad, because we didn't know what to make of it either. You see black regions, you see bright regions, you see a mishmash of features. You don't see a heavily cratered surface. This doesn't look like Mimas. Doesn't look like any of the other satellites, so obviously the surface had been altered. Next is a mosaic made of this very same region. And you could see a few round things. There's a crater over there, a caldera. There's channel-y looking things. But in any case, it was very, very difficult for us to make sense of what we were seeing on this moon. And then a very amazing thing happened. 6 months after we arrived in orbit around Saturn came what many regard as Cassini's highlight of the exploration of Titan, and that was the deployment of the Huygens probe. This was a flying saucer-shaped device that was deployed to Titan on Christmas of 2004, arrived on Titan in January of 2005, and successfully drifted down through the hazy atmosphere of Titan on a piece of fabric and came to permanent rest on its surface. And I can tell you this was an extraordinary event, and it was like a Jules Verne adventure come true, the day that humanity landed a device of its own making in the outer solar system. And it was a day that I think we should have been high-fiving all over the planet. Okay, it was a day of such significance that I've gone around saying it should have been celebrated with ticker tape parades in every major city across the globe. That's how important it was. And as you know, that didn't happen. And it was extraordinary for another reason. Cassini is a joint American-European mission. And as I sat there, and I was a spectator, I didn't have to do any work, which was fine by me. I was just a spectator watching everything. And I couldn't help but notice that the celebratory presentations were given in American accents and English accents and Italian and French and German and Dutch accents. It was just an incredibly moving demonstration of what the words United Nations is supposed to mean. And that is a union of nations truly joined in a common cause, and in this case, the cause to come to explore and understand a remote alien planetary system that for all of human history had been unreachable, and now we had touched it with something of our own making. It was a historic day, a very special day, a day that I'm not likely to forget, and I don't think anybody else should forget it either. But I digress. The probe, on its 2.5-hour trip down to the surface, took measurements of pressure, temperature, atmospheric transparency, composition, wind speed, and it also acquired pictures. In fact, it acquired panoramic pictures because it spun down as it fell. And it really would be hard to describe what it was like to see for the first time the pictures from Huygens of the Titan surface. They were stunning, and this is what they look like. These pictures were everything that our pictures from orbit were not. They were shockingly easy to interpret because this pattern is clearly, unambiguously, a drainage pattern that could only have been produced by flowing liquid. You can even follow the channels. This is clearly some kind of shoreline. This picture was taken from 16 kilometers altitude. The next picture was taken from 8 kilometers altitude. Now it's colored, but it's the same region. This is a shoreline, and you can see the channels leading down to this region here. This is 8 kilometers. The previous image was 16 kilometers. I just want to remind you that if you got in a jet and you flew from LA to New York, you would be flying at something like 11 or 12 kilometers. So this view is not unlike the view that you would have out the window of Titanian Airlines as you flew across the surface of Titan. And then finally, of course, the probe came to rest on the surface. It landed essentially in the equivalent of a Titan mudflat. Very likely the accumulation of organic residue that had fallen out of the skies over millennia and eons and millions of years and collected in low-lying basins like this dark region where the Huygens probe landed. So it was an enormously successful part of the Huygens-Cassini mission. The images that were collected helped us interpret our images from orbit, and so it was just wonderfully successful. But by this time in the mission, which is early 2005, we hadn't seen any large bodies of liquid hydrocarbons like we expected, and we were very puzzled. And it got even more puzzling when the radar instrument discovered that the equatorial region of Titan is girded by dunes. This is hundreds and hundreds of miles of dunes. In fact, they go entirely all the way around the planet in the equatorial regions, at least in the dark areas. And they're about 100 meters high, several kilometers separated from one another. They divert around obstacles. They behave just like dunes. And dunes form, as you know, where there are dry conditions and there's steady prevailing winds, and you can actually loft particles to create these dunes. And then finally, Cassini got the opportunity, being in an inclined orbit, to look at the poles. And in June '05, we got our first look at something that came close as we had seen up until that point, to something that looked like a lake. Here it is. This is one of our images that crosses the exact South Pole on Titan. And we were so confident this was going to turn out to be a lake, we called it Lake Ontario, because it is about the same size in absolute terms as Lake Ontario here on the Earth. And later on in the mission, the radar team got a very good look at this. Again, by design, we're in orbit, and that means that we can adjust and we can accommodate. If we find something early on in the mission, we can change our plans and go look at it later on. And that's what happened here. The radar instrument got a beautiful SAR, synthetic aperture radar image of Lake Ontario, and you could see river deltas that form at the ends of outflow channels or river channels. Here is a bay. And the spectral signature from this feature now tells us that it is filled with liquid, with methane, ethane, propane, and so on. When we looked in the north, the same thing happened. These are, I believe, the size of the Caspian Sea, but if you actually scaled it up to the size of the Earth, if you scale Titan up to the size of the Earth, this feature here would be the size of the Mediterranean. And then again, the radar instrument came behind us and took a swath across part of this feature, and this is what they saw. Again, the same thing, a shoreline that looks like the coast of Maine, and river channels that clearly lead down into this basin. This is a sun glint off the North Polar Sea. After decades of speculation of what might be under the haze on Titan, we now know. What we have found is an utterly remarkable place. The only place in the solar system where we have organic compounds ponded on the surface and suffusing the atmosphere. A place that is exotic and alien and at the same time strangely Earth-like and familiar. And a place that in all the solar system, in its complexity and its geologic and geographic diversity, is rivaled only by the Earth itself. So expect to hear a lot about Titan in the years ahead as Cassini progresses, because it has become one of our main objects for study in the extended mission. And now on to my absolutely favorite moon, Enceladus. Enceladus is a small little moon, only 500 kilometers across. You could see it here compared to Great Britain. This is, by the way, not meant to be a threat. Okay? And this is about the resolution. This is a Cassini image of Enceladus, but it's about the same resolution, the best resolution that we had on Voyager. And on Voyager, we could see that there were regions that looked like they was completely crater-free. And I've already told you, if a surface is crater-free, it means something's happened to it, because if nothing had happened to it, it should be as cratered as Mimas. And then when we get there with Cassini, we are totally blown away, because this is what we find. This is a surface of Enceladus at 10 times better resolution than the previous picture. You can see it is completely tectonically racked, creating canyons, mountains, a few craters here and there, but just a very complex geological history, unlike the geological history of any other body in the Saturn system. And by far, the mother lode of discoveries that we have made on this moon is at the South Pole. And this whole region is characterized by a pattern of fractures, and you know when you see patterns, that means something really good is about to happen. The patterns here in this actually false color image are a different color. That's because the physical characteristics of the ice along these fractures is different. This entire region is elevated in temperature, hotter than anywhere else on the moon. These fractures are hottest of all. And in fact, there are individual small-scale hotspots along these fractures, and there is many, many times more heat coming out of those hotspots than comes out on average out of the Yellowstone region in Wyoming. Okay, so this was a totally bizarre, unexpected result. It's as bizarre as if we found on Earth that the pole was hotter than the tropics. And what got even more exciting is when we put ourselves in a position to look over the south pole of Enceladus in the direction of the sun, this is what we saw. We saw these jets of tiny icy particles shooting up out of the South Pole, extending hundreds of kilometers above the moon. And when you take a picture like this and you process it so as to bring out the low light levels by coloring them instead of using black and white, this is what you see. These jets are feeding a gigantic plume that works its way out of Enceladus orbit and into orbit around Saturn, forming a gigantic ring called the E-ring in which Enceladus is embedded. In July of '05, Cassini flew through this plume, and the instruments on board all told us that these water ice jets are accompanied by water vapor laced with simple organic compounds like methane and carbon dioxide and propane and benzene and formaldehyde, hydrogen cyanide, a little bit of ammonia. And all of these data taken together and analysis of other images like this, like this, like this, and 5 years worth of data collection on Cassini now strongly suggests that these jets are geysers that erupt from pockets of salty liquid water beneath the surface. And the most plausible reason that anybody, or explanation that anybody can come up with for why Enceladus is as warm as it is, starts with liquid water somewhere in this moon, either as a sea beneath the South Pole or as channels or cracks that are shot through the moon but filled with water, or something like that. We are now more confident, we're growing more confident all the time that Enceladus is presenting to us not only an environment of excess warmth and organic compounds, but also one in which salty liquid water is present. Or in other words, an environment where prebiotic chemistry and perhaps life might be stirring. And so fascinated are we with this possibility that we are now taking every opportunity we can to hone in on this region. Here is a beautiful image we took only last November on one of these very close satellite flybys. You can clearly see now that these jets, they're all lined up. They're coming from those fractures. Okay, big cracks in the surface through which are emerging these geysers. It's not clear, of course, right now, because Cassini is not equipped to answer the question as to whether or not extraterrestrial life has started on this moon. But should we ever make such a discovery anywhere in the solar system, whether it's on Enceladus, whether it's in the ocean underneath the surface on the Jovian moon Europa, whether it's beneath the ice cap on Mars, should we ever find that life had arisen twice, that Genesis had occurred independently twice in our solar system, then I think at that point, the spell is broken, the existence theorem has been proven, and from that we could safely infer that life was commonplace throughout the universe, was not a bug, but a feature of the universe in which we live, and had occurred a staggering number of times in the 13.7 billion years of cosmic history. And until we get to that point, I hold a very fanciful notion that one day in the far future, our distant descendants will journey back to the Saturn system to visit the Enceladus Interplanetary Geyser Park. in a spaceship that is not dissimilar from the Starship Enterprise. And so, Cassini, of course, continues to orbit Saturn. It continues to find one remarkable discovery after another. And when it's all done in the year 2017, I think it's safe to say that it will go down in history as one of the most scientifically productive missions that was ever flown. But in the end, the story of Cassini, like the story of all our other interplanetary explorations, is really a story about longing. It's longing to understand ourselves, longing to know us. And one of the images that we have taken at Saturn says this better than the spoken word ever could. And it's a picture that was taken in late 2006 when we could witness something that no human had ever seen before. And that was a total solar eclipse of the sun seen from the other side of Saturn. And in this picture, you see the backlit image of the rings, and you see this glorious blue ring that is created from the spray of the moon Enceladus. But if you look closely, you can see across 1 billion miles of interplanetary space our own little planet Earth nestled in the arms of Saturn's rings. There is something tremendously moving about seeing ourselves from afar as we would be seen in the skies of other worlds. It is a powerful recognition that stirs within us. And in fact, to me, this is a picture where the Italian astronomer Galileo Galilei and the biologist Charles Darwin come face to face, because it's a picture that shouts evolution. I look at this picture and I see our distant ancestors stepping down from the trees and walking upright for the first time onto the African savannas and pausing to look back at the forests from which they came. And I look at this picture and I see a species that is positively unyielding in its pursuit of knowledge and brave and ardent in its longing to grasp the meaning and the significance of its own existence. And finally, I can't help but look at this picture and see the very best that humanity has to offer. Because we are, no doubt, the troubled and warlike inhabitants of one tiny little planet, but we are also the dreamers, the thinkers, and the explorers who took this picture. One world, clear across interplanetary space to another. To be so small and to reach so far is what makes us the extraordinary citizens of planet Earth. Thank you.
It's an interesting speculation that the conditions for life to have arisen may be closer than we ever thought, and that it could be that even on our own solar system there are the right conditions for life to arise. These moons of Saturn, which have organic compounds and water on them, those are the basic conditions that you need to make life. Of course, it's a long step from that to say that you've got life. The origin of life, the event that was the origin of life, which was the first arising of a self-replicating molecule, a molecule that makes copies of itself, that may or may not have been a tremendously improbable event. But as Carolyn said, if it turns out that there is the starting of life, the rudiments of something like bacterial life, twice in one planetary system, then that immediately means that our estimates of the amount of life in the universe shoot up to, we have to say that the universe is simply crawling with life.